Hey, hey, I am Oguz, and in this presentation I will talk about SIMD operations in WebGPU for machine learning. Slide 2. This is a high-level presentation that doesn't go into too much technical detail. Slide 3. Subgroups are the subdivision of thread groups. They are also named as SIMD groups, warps, and waves, and their operations can make sharing and reducing data across threads in a subgroup measurably faster. And we can have these operations in WebGPU shading language. Slide 4. It's fast to share data between threads in a thread group thanks to the shared memory, but it's faster to share data between threads in a subgroup because they don't even have to go to shared memory. Slide 5. The desire is containing as much sharing and calculation as possible in these SIMD32 blocks, and subgroup operations are a great way to do that. Slide 6. Subgroup operations reduce runtime and power consumption, which can have critical impact on exploratory data analysis, model fine-tuning, and edge inference applications. But besides, subgroups also bring an intuitive mapping to hardware for your algorithms because GPUs have no atomics or advisable locking mechanism for floating point numbers, at least one that will get exposed in the WebGPU. Slide 7. Subgroup operations in WebGPU shading language are compute stage only, active threads only, and have a non-uniform execution model. Slide 8. The meaning of active threads here is in case of a divergence inside a subgroup, the operations provided will only execute across threads that can make to these operations together. Slide 9. Let's get started with the basic operations. Subgroup size gives us the number of threads in a subgroup. Invocation index gives us the index of our thread inside the subgroup. And subgroup is first gives us whether we are the first invocation among the active threads. Slide 10. Subgroup all returns true to all invocations in case all invocations provided with true, and any returns true in case at least one invocation provides true. Slide 11. Arithmetic operations essentially provide you with reduction, addition across invocations, multiplication, minimum, maximum, and or exclusive or. But it's important to note that these operations will take place across active threads, and they can, besides scalar numeral values, they can take vectors too. Slide 12. Prefix operations provide us with the summation or multiplication of invocations with an index less than the one we are inspecting. Slide 13. Subgroup ballot returns a bit field where the bit is 1 in the corresponding invocation in case the invocation provided true to the ballot operation, and subgroup broadcast first broadcasts the value in the first lane, the first active lane, to rest of the invocations. Slide 14. On desktop, subgroup operations are available everywhere, at least the target of WebGPU, and on the mobile, most of the next generation chips support them. Slide 15. Technically, subgroup operations can make it into MVP as a good addition in the standard library of WebGPU shading language because the raised concerns mostly fall out of scope for this PR and not blockers for adoption as is. slide 16. Thanks, and you can check out the PR itself to see more and reach out to me for anything related to subgroups. Have a nice and healthy day.